So we're looking at chapter 9.2, number 29 here. So we're looking to graph the function. I'm not going to do like a perfect job of graphing it. I'll also try and grab a quick little chart for us here so it's not quite as horrendous as it would have been otherwise, because me freehanding things, it's just that, it's horrendous. So we start out by looking at what we care about the most in terms of doing these hyperbola problems, and that is going to be my vertical asymptote. So when we're looking at this thing, that's kind of the first step in my process for solving this problem. So when I look at this one, I'll get rid of all the excess so we can just focus on 29 here. So we are just looking at where this thing is not going to exist, basically. So where am I going to have an issue in my denominator? So the issue for my denominator is going to stem from where it is 0, right? The thing that I cannot do besides fly, no matter how bad I want to fly, is that I can't divide by 0. We also can't take even roots of negative numbers, but that's kind of like a separate thing. The stuff we're focusing on is going to be around this denominator. I'm going to say 4x plus 12 is equal to 0. Okay, cool. Well, where is this going to be equal to 0? I would subtract my 12. Now I have 4x equals negative 12. Divide by 4, and I get x equals negative 3. So the significance of this is that this is my vertical asymptote. So V, and that thing is x equals negative 3. So that's the first thing I'm going to put on here, and I'll also slap it on my graph, just like that. If you wanted to wait and add it to your graph afterwards, that's totally fine. I'm just kind of like doing it piece by piece as I go. The next thing I want to look to here is going to be my horizontal asymptote. So if you have done some of the 9.3 stuff, you could say, oh, Mr. G, why don't you take that negative 2, which does not have a denominator seen here, so we know its denominator is 1, and why don't you just combine it with that 4x plus 12 denominator thing, so you have it all over the same term, and then you can do the ratio of the leading coefficients. I would say you are right, but this is a sort of simplified version, so we can kind of take the easy route here. The easy route here is to look for the k value, which is just hanging out on the outside. This negative 2 is my k value. So if my k value is negative 2, that means that I'm going to get a horizontal asymptote at y equals negative 2. So I'm going to draw that on my graph as well. Looks something like that. So now that I've got those two on there, that's sort of defining my kind of like directional high Y guardrails there. So I know I'm going to either be up like this or up like this and down like this and down like that. So just trying to determine where that's going to happen. So I want to start plotting points, and I want to do it relative to where my vertical asymptote is. So here we say an x and a y. My vertical asymptote went right through negative 3, so I'm going to put negative 3 in the middle. And then what spits out? Nothing. We cannot evaluate that point. It does not exist. DNE. And then I want to go 2 units to the left. So I'll do negative 4 and negative 5. And I'll also do 2 units to the right, negative 2 and negative 1. And I'm going to plug these values in. So if you want to just do this on your calculator, or you want to use like a table in Desmos, like that's fine to kind of shortcut the math a little bit. I'm going to enter this on my calculator just so I don't make a mistake on live TV, because boy, that would be embarrassing. But I will walk you through some of these individually. I won't do all of them, but we will do a few. Let's see. So I've got my graphing calculator going here. I'm going to go set my table so that I can check it out. And I'm going to go check that out. And I am good to go. Okay. So now let's talk about these values. I'm going to write the first couple as fractions. If you want to write them as decimals, that's okay. With these ones, it ends up coming out pretty clean. But by and large, on graphs with hyperbolas like this, it's not going to be something that we care a ton about the accuracy, but we would like to at least get these first few points. So let's plug in negative 5 and see what happens. If I plug in negative 5 into this equation, what's going to happen? I'm going to get negative 5 times 4 on the bottom. So negative 5 times 4 is negative 20. Now I have negative 20 plus 12. Negative 20 plus 12 gives me negative 8. So now I have negative 1/8, and then I have minus 2. And I say, okay, well, what is that? That's now going to be negative 17/8, which is the same thing, because it's eighths. It's a nice number. It's not like non-terminating decimal here. So I'm going to get negative 2.125. And that is my point there. So roughly speaking, let's see, negative 5, negative 2 and a little bit would put me right about here. As long as it's between the value and the next value, like as long as it's between negative 2 and negative 3, don't worry about it much more than that. So now I want to do negative 4. So when I plug in negative 4, what do I get? I get negative 2.25, aka negative 9/4, whichever you prefer. So now I'm going to say again, it's a little bit lower, but it's really hard to show that. So there's me attempting to draw it slightly lower. But basically what's happening is that it's going kind of up to the left, and I'm going to approach but not actually touch that green line there. And I'm going to do the same thing, approach but not actually touch the red line there. So I've now graphed the left half of my hyperbola here. Next, I'm going to go over to these 2 points, negative 2 and negative 1. I'm plugging those in just the same way. I'm just going to use the decimals here. So I get negative 1.75 and then negative 1.875. So if I were to again graph these 2 points, it would look something like this, and I'm kind of exaggerating these a little bit to try and just show you that it is curving up like that and curving down to approach flat like that. So now let's talk about the domain and range of this thing. So now we've got it graphed. We can see there's one spot where we can't put a value in. That is our vertical asymptote. So my domain is all real numbers except x cannot equal negative 3. For my range, I again see that I am all real numbers except y cannot equal negative 2, my horizontal asymptote here. So there we've graphed the function and stated the domain and range. Any questions on that one?
So here, the domain and range, is it always going to be all real numbers except the asymptote?
So the question is, will the domain and range always be all real numbers except the asymptotes? For this type of a problem, yes. For others, which we'll see in 9.3, it will change a little bit. Let's say, for example, I was doing a problem that was 1 divided by x squared plus 1. So that's not something we've done so far, but it is something we will do. If that were the case, there will be some values that I cannot reach. Good question. What else we got? Perfect.